Okay, today we're going to cover section 6.3 and section 6.4, and the next time we're going to cover two more sections to finish the chapter. And with that, we're going to have our next exam on Wednesday next week. It's going to be an online exam, your first exam that is going to be online. It's going to be very similar to the quizzes that you have been solving online. So it's going to be one more quiz. This time is going to be your exam. And the only difference with respect to quizzes is that you're going to need to do this exam with limited time. So you're going to have 2 hours to finish your exam. And also you need to download an extension for Chrome to be able to go on the quiz. It's from Proctorius. I don't know whether you are familiar with that, but I'm going to give you the web page at the end of the session today. So, and more information after the break. So today we're going to cover section 6.3, which is on page 438, and it's about factoring trinomials whose leading coefficient is not 1. So your book starts with some guessing method, but later on page 441, they introduce the method that they call factoring by the grouping method. The grouping method. You can find this method in other books known as the AC method. The AC method. And the good news is that we already used this method the last time that we worked with the trinomials with leading coefficient equal to 1. So this is going to be a repetition of what we learned on section 6.2. So let's start with examples. So we're going to have example 1 on page 439, and we're going to need to factor. We're going to factor 3x squared minus 20x plus 28. So that's my trinomial. This is a trinomial because it has 3 terms. This is A, this is B, and this is C. So this is a trinomial of the form A x squared plus bx plus c. So the AC method is just you're going to multiply A and C. So you're going to look for two numbers that if you multiply them, you get AC. In this case, is 3 times 28. So 3 times 28. So this is going to be 24. It's going to be 84. So we need to look for factors of 84. And also, we need those two factors to satisfy the next condition, which is that if you add them up, you're going to get the middle term. The middle term in this case is negative 20. So we need to guess numbers that if you multiply them, you get 84, and if you add them up, you get negative 20. So what are those numbers? So we need to start guessing. So we have, for example, 28 can be decomposed as 7 times 4. So I'm going to look for factors that are going to give me 20. So let's see. Another possibility is that you can multiply 14 times 2. That is going to be also 28. So if we have 3 times 2 is going to be 6 times 14. The product is going to be 84. And if you add them up, you're going to get 20, because 6 plus 24 is going to be 20. So these are my candidates, but the only problem is that 6 plus 14 is positive 20. I need negative 20. So what I need to do is just write negative 6 negative 14, so I can get negative 20, and also negative 6 times negative 14 is going to give me 84. So these are my candidates, these are my factors. So I'm going to use these factors to break the middle term. So the first step is just finding factors satisfying these conditions. Then the second is we're gonna rewrite the trinomial by breaking the middle terms as we did the last time. We're gonna break the middle terms. So in this case, my first term is just 3x squared. Then I have negative 20x. I'm going to break negative 20x by using these two numbers. So one is going to be negative 6x, the other one is negative 14x. So now negative 6 and negative 14 is negative 20x. So I just broke my middle term. And then the last term. So now that you have this, the next step is we're going to do factoring by grouping. So we're going to factor by grouping. So this is just a repetition of what we did the last time. Just check the notes. So factoring by grouping means that you're going to group the first two terms and the last two terms, and you're going to find greatest common factors for each. So what is the greatest common factor for the first group? So what is the number first, the coefficient that divides, or the number that divides both coefficients? Is going to be 3. What is the variable that divides both terms? Is going to be x. So my greatest common factor for the first term, for the first group, sorry, is 3x. So I'm going to divide 3x squared minus 6 over my greatest common factor. So that's with respect to the first group. The second group, what is the greatest common factor for coefficients? So you can see that negative 14 works for 14 and for 28, and you don't have the variable showing up in both terms, so there is no greatest common factor for variables rather than just one. So I'm going to write negative 14x plus 28, and I'm going to divide every term by my greatest common factor. So now it's time to simplify everything that is inside of parentheses. So I'm going to keep my 3x outside. Then 3x squared over 3x, 3 cancels with 3, x squared over x is going to be just x. Then negative 6 over 3 is going to be negative 2, x cancels with x. So then I have negative 14, my greatest common factor for the second group. So negative 14 over negative 14 cancels. So I just get x. Then 28 divided by negative 14 is negative 2. So the important thing when you are doing factoring by grouping is that you get the same binomial multiplying two different factors. So this is my common binomial. If you don't get these two parentheses the same, then you made a mistake and you need to start over again. So I get my common binomial. So the answer is writing that common binomial. And then the other factor is going to be just the greatest common factors that you found before. So 3x was my first greatest common factor, and negative 14 my second common factor. So you can say that the second binomial is just the binomial of the greatest common factors, and the first one is the common binomial. So this is the solution for this problem. So that's example 1. So I'm going to solve 2 more examples, maybe 3 more examples, and then you're going to be able to play with these things. I'm going to solve as many as possible. So let's work on example 2. So example 2 is on page 439. So I'm going to factor a x squared minus 10x minus 3. So again, this is a, b, c. So this is my trinomial, I need two numbers that when I multiply them I get AC. In this case is A times negative 3, so this is going to be negative 24. And also those two numbers that I'm going to find, if I add them up, I'm going to get the middle term, in this case negative 10. So I need to start looking for candidates. So two numbers that if I multiply them I get negative 24, might be 2 times 12, negative 12, to get negative 24, and if I add them, 2 plus negative 12, I'm going to get negative 10. So this problem was easier than the other one. So I have my candidate, so I'm going to be able then, so I'm going to be able to rewrite the middle term. So first I found the factors. Now I'm going to rewrite my trinomial by breaking the middle term. So the leading term is just ax squared. Then negative 10x is going to be broken by using 2 and negative 12. So 2x minus 12x. So that gives me the middle term. And finally the last term. So now I have my trinomial converted into a polynomial of 4 terms. So now I'm going to factor by grouping. So factor by grouping is just having two groups. My first group is this, my second group is this one. So what is the greatest common factor for the first group? So 2 is going to be the coefficient that divides both coefficients. 2 is going to be the number that divides both coefficients, and x is going to be the variable that divides both terms. So I have ax squared over 2x plus 2x over 2x. Then with respect to the second one, so what is the greatest common factor for coefficient? Is going to be just negative 3. For variables, we don't have a greatest common factor for variables because the variable x only appears in one of the terms. It doesn't appear in the other term, so that's the reason we don't have a variable here. So we just write negative 12x over negative 3, negative 3 over negative 3. So anytime we divide the group by the corresponding greatest common factor, then we just simplify. We have 2x, then a divided by 2 is going to be 4, x squared divided by x is going to be just x, and 2x over 2x is just 1. Anytime that you have the same numerator and the same denominator, then you just get 1. Minus 3, negative over negative is going to be positive. 12 divided by 3 is going to be 4. X over 1 is just x. And again, negative 3 over negative 3 is just 1. So, and I'm getting my common binomial now. My common binomial. So that's an indication that I'm doing the right factoring. So I'm just going to write that common binomial first. And then I'm going to write the binomial that is created by using the greatest common factors. The first greatest common factor and the second greatest common factor. So this should be the answer, and we are right. Okay, so let's continue. Let's work more problems, as many as possible. So because you're gonna have this in your exam the next week. So example 3 on page 440. Now we're gonna factor. We're gonna factor 2x squared minus 7xy and plus 3y squared plus 3y squared. So again, we have a, b, and c. So I need two numbers that when I multiply them, I'm going to get AC. So this time is just 6. 2 times 3 is 6. and then I need two numbers, the same two numbers, that if I add them up, I get the middle term. In this time, the middle term is just negative 7. So what are those factors? So immediately you know that 6 times 1 is going to be 6, and 6 plus 1 is going to be 7. So you don't need you need a negative 7. So what I'm going to do is I'm going to switch the sign. I'm going to get negative 6, negative 1, because the product is going to be positive, because negative times negative is going to be positive, and also negative 6 plus negative 1 is going to be negative 7. So I'm going to rewrite. So first is guessing factors, that's the first part. Then is rewriting the trinomial, rewriting the trinomial. I'm going to write the trinomial again for you to see that we are just breaking the middle term. So this is my original trinomial. So I'm going to break this by using the two numbers that work for me. So negative 6, negative 1. So, and then you just pay attention to the variable. So you need to attach the variable to these two numbers. So you're going to write 2x squared minus 6xy minus 1xy plus 3y squared. So this is the way that we rewrite the trinomials, by breaking the middle term. So finally we're gonna do factor by grouping, and with that we're gonna finish. So we have two groups. This is the first group, this is the second group. So what is the greatest common factor for the first group? So the first group ends here. Sorry, you don't need this piece. So what is the greatest common factor here? For coefficients, two words for those coefficients. For variables, x appears in both terms, but y doesn't. So I only have x, and the x with the lowest exponent is going to be just x, because the smallest exponent is just 1. So that's my greatest common factor for the first group. So now I'm going to write every term divided by the greatest common factor. So I'm going to get these two fractions here. Now, what is the greatest common factor? For coefficient, is going to be just negative 1. And for variables, now x doesn't appear in the second term, so we don't care about x. We only care about y, because y appears in both terms. And what is the lowest or the smallest coefficient? Sorry, the smallest exponent for y is just 1. So negative y is going to be my greatest common factor for the second group. Then I'm going to write again minus 1xy plus 3y squared over negative y over negative y. So I need to divide by my greatest common factor. So I'm going to get 2x here. Then 2 divided by 2 is just 1. And x squared divided by x is going to be just x. Negative 6 over 2 is going to be negative 3. Xy over x, you're going to get only y. Then minus y. So negative over negative is positive. X remains, y disappears, because y over y is just 1. And here you have positive over negative is going to be negative. 3 over 1 is just 3. And y squared over y, you're going to get only y. So again, we got our common binomial, which is x minus 3y. That's my common binomial. And also the binomial that is created by using the greatest common factor. So 2x, my first greatest common factor, minus y, my second greatest common factor. So that's the answer for this example. So then the book starts with examples about using on how to use the grouping method. So we already worked 3 examples, so it's going to be more the same. So example 4, is by using this method. The first three examples were just solved by guessing, a lot of guessing, not just the first factors, or a lot of products. So you can check later the book, and you're gonna see that working with this method is the best way to find the factors. So let me work example 4 on page 441. So uh, we have, and they say factor by grouping. We don't have to write factor by grouping because it's the only method that we use. 2x squared minus x minus 6. The only thing is that we need to identify a, b, and c. So a is 2, b is -1, and c is -6. So again, we're going to start finding factors of the last factors of AC. Remember, factors of AC. That's the first part. So we're going to multiply two numbers, and we're going to get AC. This times is -12. And I'm going to add those two numbers to get the middle term, this time -1. So what are those numbers? So I'm going to multiply 12 and -1. And in that case, I get -12. So I'm guessing here. This is my guessing. And also, if I add 12 and -1, I'm going to get positive 11. So these numbers don't work, right? They are very far from B, so I need other couple of numbers. Let's try 4 and -3. 4 and -3, you're gonna get 12. This is my second choice. And 4 plus -3, I get +1. So I'm pretty close. I need -1. So when I get the sum with the opposite sign, the only thing I need to do is reverse the signs of my factors. So I'm going to use -4, +3. So I'm going to get again -12, but this time -4 plus +3, I'm going to get -1. So these are the numbers I was looking for. So I'm going to use these two numbers to break my trinomial. So I'm going to rewrite the trinomial. So I'm going to write 2x squared minus x minus 6, and the middle term, the middle coefficient, is going to be broken by using -4, +3, because -4 and +3 is going to give me -1. And thus, don't forget that we're going to attach the variable to this number. So this is going to be 2x squared minus 4x plus 3x minus 6. So this part is very important. Once you do this, the rest is going to be much easier. So the third part is just doing factoring by grouping. So I'm going to group these two. I'm going to group these other two. So what is the greatest common factor for the first group? You can see that 2 works for 2 and -4, and x is just the variable appearing in both terms with the lowest exponent. So I'm going to write my two terms, 2x squared minus 4x. I'm going to divide these terms by my greatest common factor. Okay, now I have my second group. The greatest common factor for coefficient is going to be 3. That works for 3 and 6. And I don't need to do anything with the variables because the variable only appears once. So I'm going to write 3x minus 6 divided by 3 and divided by 3. So I'm just going to simplify the fractions. So I'm going to get 2x, my first greatest common factor. Then 2 over 2 is 1. X squared over x is just x. Negative 4 over 2 is going to be negative 2. X over x is just 1. Plus 3. 3 over 3 is 1, so I end up with x only. And negative 6 over positive 3 is going to be negative 2. So I'm getting my common binomial again. My common binomial is x minus 2, and the binomial created by using the greatest common factors is going to be 2x plus 3. So that's example 4. 2x plus 3 and x minus 2. So we are getting the answer that you have in your book. So one more problem. No, two more problems, and then you're going to have the opportunity to practice this. So because we're going to finish section 6.3. So example 5 on page 442. We're going to factor by grouping a x squared minus 22x plus 5. So you have a, b, and c. So we need two numbers that if you multiply them, you're gonna get AC, which is 40. So, and then those two numbers, when you add them up, you're gonna get B, which is negative 22. So we're gonna start with 20 times 2. So you get 40. 20 plus 2, you get 22. So we got B, or we got 22, but with the opposite sign. So I just need to switch signs. So it's going to be negative 20, negative 2. So the product is still 40, and negative 20 plus negative 2 is going to be negative 22. So that works for us. So these are my two numbers, the ones I was looking for. So we're going to use negative 20 and negative 2 to break the middle term. So, and that's my second step. So I'm going to write ax squared minus 20x minus 2x plus 5. So now my middle term is broken in these two pieces. So now we do factoring by grouping. So we're going to work with these two groups. So the first, so what is the greatest common factor for this, for the first group? So it's going to be 4. 4 works for 20, 4 works for 2, 4x. So I'm going to write ax squared over 4x minus 20x over 4x. Then the greatest common factor for the second group is just going to be minus 1 for coefficients and nothing for variable, because the variable only appears once. So I'm going to divide everything by my greatest common factor, which is negative 1. So you end up with 4x, and a divided by 4 is 2, x squared divided by x is x, negative 20 divided by 4 is going to be negative 5, x over x is just 1, minus 1. Now it's very important to write this negative 1. You're going to see now why. So negative 2 over negative 1 is just positive 2x, and positive 5 over negative 1 is going to be negative y. So we get our common binomial. So we are doing very well. So we write that common binomial, and then the binomial containing the greatest common factor. So it is important to write negative 1, because now we can write negative 1 here. Sometimes students don't write negative 1. They just factor out the negative sign, and then when they are trying to build the other factor, they don't know how to proceed because they didn't write negative 1. So that's example 5. So I'm going to solve the last example for this section, and then I'm going to give you problems to solve now, and you can just show me you can take screenshots. Now the process is that you're going to take screenshots and you're going to upload those screenshots through Canvas. Now I'm including a link for you to upload your classwork. So no more emails, no more text messages. Now you're going to use Canvas and you're going to upload your screenshots there. Okay, so let's finish by solving example 6. Example 6 on page 442. We're going to factor completely. So when they say completely, they mean that maybe you need to get a greatest common factor, a general one for the entire trinomial, and then proceed with the subsequent method. So we have 15y to the 4 plus 26y cubed and plus 7y squared. So you can see here that y appears in the three terms. So there is no greatest common factor for the coefficients because you don't have a number that divides evenly 7, 26, and 15. Just one is the one that. But in the case of the variables, you know that you can get the greatest common factor for the variables is going to be y squared because y appears in all terms and you use just the exponent that is the lowest one. So then you're going to divide everything by your greatest common factor. So we are just applying what we learned the last time before proceeding with factoring the trinomial. So when you do this, you're going to end up with y squared, 15y squared plus 26y plus 7. So that's the second part. Then you're gonna factor this trinomial. So you have a, b, and c here. So let's see. So we're gonna multiply two numbers to get AC, which is 15 times 7. I'm not doing the operation because sometimes when you have big numbers, it's better if you leave this indicated because you're gonna break just one of the numbers and play with the possible products to get those factors. So the second part is that you're gonna add up these two numbers and you're gonna get B. Let me write this well because you're gonna add them and you're gonna get B, which is 26. So there are what are the possibilities? So we have if we multiply these two, if you add these two, you're gonna get 15 plus 7 is just 22, so it doesn't work for this, so we need to break this number. So 15 can be broken as 5 times 3, and we have 7. So now we can combine these two, so we can get 5 times 21. So 5 times 21 is the same as 15 times 7 because I'm using the factors of 15 here. So, and I can see, so this is equal to 15 times 7, and I can see here that if you add up these two values, 5 and 21, you're gonna get 26. So 5 and 21 are my numbers. Okay, so I'm going to rewrite my trinomial. I'm going to rewrite the trinomial, but without removing my greatest common factor that I found before. So I need to keep my y squared here that I found here that I factor out. So I'm going to write again 15y squared plus 26y plus 7, and we're going to break this middle term. We're going to use 5 and 21 to break 26. So we're going to get y squared that multiplies 15y squared plus 5y plus 21y plus 7. So now I have my trinomial broken. So now I'm going to do factoring by grouping of these two groups. So what is the greatest common factor for these two elements? So it's going to be phi for coefficients and y for variables. So I'm going to divide phi y squared over phi y and plus phi y over phi y. Then for the second group 7 works for both and no variable involved. So I'm going to get 21y over 7 plus 7 over 7. So I'm going to get, and this is multiplied by y squared. You can omit this and include at the end y squared. So when I have 5y that multiplies 15 over 5 is going to be 3, y squared over y is going to be y, and 5y over 5y is just 1. Then we have 7, 21 over 7 is 3, y again plus 1 because 7 over 7 is 1. And this is multiplied my greatest common factor that I found at the very first step. So I have my common binomial. So I'm going to write my common binomial. Then I'm going to write the binomial with the greatest common factors. And then I'm going to write y squared, which was my first greatest common factor that I found before. So the answer then is y squared times 3y plus 1 times 5y plus 7. So now you're going to work some exercises now, and you're going to upload your work, and if you want to show me your answers or tell me your answers by using chat, I can check with my book. Otherwise, you can continue with this work later at home, later in your home. So we have 6.3 exercise set on page 443. So you're going to work problem 4. Problem 4, you're going to factor 2x squared plus 7x plus 3. Then we have problem 8 is 5y squared minus 17y plus 6. Then you have problem 12, which is 3x squared plus 14x minus 5. Then problem 16, which is 5y squared minus 8y plus 3. And finally problem 20, which is 6w squared minus 17w plus 12. So you have 5 exercises to work now. In the meantime, I'm going to stop the recording and then we can check your work. So section 6.4 is on page 446, and now is factoring. It's about factoring special forms. So what are those special forms that we're going to cover here? So factoring special forms, we're going to use just formulas. You're going to use formulas as shortcuts to factor. So those formulas are going to be our shortcuts. So we're going to have something like this: a squared minus b squared. That's our first case that we're going to study today. Then we're going to have a squared plus minus 2ab plus b squared. And finally, we're going to have something like a cubed plus minus b cubed. So the first one. So we're going to have, the first one is factoring the difference of two squares. So we're going to factor the difference of two squares. This is on page 447. So it's a squared minus b squared. So you have the difference of two perfect squares. So what is the formula? The formula is that you're gonna use you're gonna have the product of two conjugates. So a plus b is a binomial. When you have a binomial where the first and the last term are the same and you switch the middle sign, then this is the conjugate. So these are conjugates. So these are uh, conjugate binomials, because the only difference is the middle sign, the sign in the middle. So these are conjugate binomials. So when you have the difference of two perfect squares, the way that you're going to factor this form is just by writing the product of two conjugates. So the only thing that you need to do is just finding or checking that you have two perfect squares. So I'm going to solve example 1. Example 1. Example 1 on page 447 is first case. We have x squared minus 4. So this is the difference of two terms. So the first thing is we need to be sure that we have two perfect squares. The best way to determine that is that you need to rewrite the first and second terms as perfect squares. So this is important, that you are able to write the first and the second term as perfect squares. So I have x squared minus 4. So how do you write this as a perfect square? You use parentheses. So you can write x squared, so this is a perfect square, and 4 is 2 square. So you can see here that this is a perfect square and this is another perfect square because we can write them as perfect squares. So once you do this, you're going to know that what is inside of every parenthesis is your A and your B that you are looking for. So I have A and B. So now I can write the answer. So this is going to be A plus B, A times A minus B. So A is X and B is 2. So I'm going to write plus 2 times X minus 2. So that's the first example. That's the first part of the first example. Let's repeat the process. We're going to repeat this process many times in this section. So we have 81 x squared minus 49. So that's my binomial. So I need to determine whether these are perfect squares or not. But first, you need to check that you have the difference, because if you have the sum, then you cannot factor a sum of perfect squares. So I'm going to write this at the end, so don't forget that. So I'm going to write first this as a perfect square. So you can write 81 as 9 squared and x. So this is the way that you write 81x squared as a perfect square. So I'm just getting the square root of 81 is 9. I'm getting the square root of x squared is x. Then you square it, and that's my first term. The second term is just 7 squared. So now you have two perfect squares. So this is A and this is B. So now I can rewrite this as 9x plus 7 times 9x minus 7. So I write the first binomial and then I write its conjugate. So that's the best way to solve these problems, by using this shortcut. So I have two more. So let's work example 2 on page 448. So the first problem is I'm going to factor 9 minus 16x to the 10. So now I'm going to rewrite again this as perfect squares. So 9 can be written as 3 squared. Then 16 can be written as 4, and x to the 10. So any variable that you have with any coefficient, usually it should be even an even coefficient, but any coefficient can be written as a perfect square if you divide that coefficient by 2 and then you square the result. So that's the way that you rewrite a variable as a perfect square. So this is to rewrite a power of x as perfect square. Okay, so in this case, x to the 10, how do you write x to the 10 as a perfect square? You're going to divide the exponent by 2, so it's going to be 5, and then you square the thing. So now you have everything as perfect squares. So now you know that this is a, that this is b, so the rest is just very simple. You just write a plus b times a minus b. So that's the first problem. The second problem from the same example is 25x squared minus 4y squared. So again, we need to rewrite this as perfect squares. So the first one, what is the way that you're going to write the coefficient? Is going to be 5, because 5 squared is 25, and x squared is just x, and then you square everything. Then 4, the square root of 4 is 2, y squared, the square root is y, so you're gonna get 2 perfect squares, the difference again, the difference. So then this is a, this is b, so you're gonna have 5x plus 2y times 5x minus 2y, and that should be the answer. So again, the sum of 2 perfect squares cannot be factor. Okay, this is important. Only the difference. If you have the sum, if you have a squared plus b squared, you say that this is a prime, is prime. You cannot factor the sum of 2 perfect squares, only the difference. So let's work two more examples, and then you're gonna practice this. So we have 7. Okay, so example, what is the next example? 3. Example 3 on page 448. So we're gonna factor 12x cubed minus 3x. So this is cube and 3x. So these are not perfect squares, but you can check whether you can factor out the greatest common factor. So what is the greatest common factor here? So we're gonna factor the greatest common factor first. So it's gonna be 3, because 3 works for 3 and 12, and it's gonna be x. So if I divide every term by the greatest common factor, I'm going to get 3x that multiplies 12 divided by 3 is going to be 4. X cubed divided by x is going to be x squared minus, and the numerator and the denominator are the same, so this is just 1. Now inside of this parenthesis, we have the difference of 2 perfect squares. So we can factor that part by using our formula. So we only need to rewrite this as perfect squares. So what is 4x squared written as a perfect square? Is going to be 2x squared. What is 1 written as a perfect square? Is going to be 1 squared. So this is A and this is B. So you're going to write this as A. Don't forget your greatest common factor, 3x, then A plus B times A minus B. So don't forget this, because this greatest common factor was obtained from the first step. So you're going to have 3x. A is 2x plus B, which is 1, then 2x minus 1. Then we have one more example, B. So 80 that multiplies negative 125x squared. So 80 is not a perfect square, 125 is not a perfect square, so maybe we need to factor out something. So you're going to check here and you're going to see that 5 is the greatest common factor for coefficients. So we're going to have 80 over 5 minus 125 over 5x squared. So if we simplify this, we're going to get 16 minus 25x squared. So now we can write this as a 4 squared. This is going to be 5x squared. So this is my A, this is my B. So I'm going to write 5, which is my first greatest common factor, A plus B, A minus B. So the final answer is going to be A is 4 plus 5x times 4 minus 5x. So that's the problem. So let's solve the last problem, and then you're going to have time to check some examples. So this is going to be example 4 on page 449. So now we're going to factor completely. So x to the 4 minus 81. So x to the 4. So are these perfect squares? Yeah, they are. We need to just to write this as a perfect square. So how do you write x to the 4 as a perfect square? You're going to write x, you're going to divide by 2 the coefficient. So 4 divided by 2 is 2, and you're going to square. And then you have 81 is just 9 square. So you have A, you have B, so you have x squared minus 9 times x squared plus 9. Now, remember, the sum of two perfect squares cannot be factored, so we cannot do anything with this, but we can do something with this because this is the difference of two perfect squares again. So you can write this as x squared minus, and this is 3 squared. So this is my new A, my new B. So I'm going to write x plus b. So it's going to be x plus 3 times x minus b times the sum of two perfect squares that I couldn't factor. So this is the final answer for this example. So now I'm going to give you problems to solve now or later. And remember, you're going to submit some of those exercises to get your class points. So you're going to solve from exercise set 6.4 exercise set 6.4 exercise set on page 453. We're going to solve problem 4, y squared minus 9. Problem 6 is going to be 9x squared minus 25. Then problem 16 is 49y to the 4 minus 25. Problem 12 is 16 minus 49y squared, and finally, I think those are sufficient, only 4 problems, no more than that. So you're going to solve those problems. I'm going to give you a couple of minutes to solve those problems. In the meantime, I'm going to stop the recording. So on page 449, we have factoring perfect square trinomials. So now we're going to have something like this: a squared plus 2ab plus b squared, and you're going to get from this expression something like a plus b squared. So that's going to be the way to factor. This is also equivalent to say a plus b times a plus b. So this time you are not multiplying conjugates, you are multiplying the same binomial by itself. So the other option is when you have a negative middle term. So then you just get the difference, a minus b squared, which is also a minus b times a minus b. So again, you're multiplying the binomial by itself. So this is not the product of two conjugates as we had before. So the way that we're gonna do this is very similar to the way that we did the previous one. So we need to check that the first and the last term are perfect squares. So the first thing is just rewrite the first and last terms as perfect squares. Then we're gonna obtain two AB and compare with the middle term. If they are the same, then you just write the binomial and and you're going to square the binomial. So that's those are the steps. So let's start with one example. So I'm going to start with example 5 on page 450. So we're going to factor, and the first exercise is x squared plus 6x plus 9. So I have now a trinomial. So I want to know whether this is a perfect square trinomial. So this is what I want to know. So that's a question mark. So is this a perfect square trinomial? Let's check. So I'm going to rewrite the first and the last term as perfect squares. We did that before for the previous example. So what is the way that you write x squared as a perfect square? You just have x squared. How do you write 9 as a perfect square? You write 3 squared. So a is x, b is 3. So you know that from previous exercises. So now what is 2ab? 2ab is going to be 2 times a, x, times b is 3. So you're going to get 2 times 3, 6x. And you check that this value is the same as your middle term. If they are the same, then this is a perfect square trinomial. So you just need to write a plus b squared as your answer. So what is a? A is 3, is x. A is x, and b is 3. So something important to remember is that this sign in between, matches the sign of the middle term, always. So this sign matches the sign of the middle term. of the original trinomial. Okay, that's important to check. The middle term of the original trinomial. I'm going to solve more problems, so we're going to practice this a lot. So the next exercise is B. So B, we have x squared minus 16x plus 64. So is this a perfect square trinomial? Let's see. So we're going to write this as a perfect square. So this is also x squared. Then we have 64 can be written as 8 squared. So now this is A, this is B. So we find 2AB is 2 times x, 2 times b, which is 8. So this is going to be 2 times 8 is going to be 16x. So this and this match. So there is a match. So there is a match here. So that means that then the trinomial is a perfect square. So then you can write just a plus b or minus b. In this case is minus b because this sign is negative. So you're going to write a minus b squared. So this is just a is x, b is 8, so is x is 8. So you're going to have x minus 8 squared, and that's the answer. Okay, so let's solve the last one from example 5. So the last one is 25x squared minus 60x plus 36. So is this a perfect square trinomial? We don't know. Let's rewrite the first term as a perfect square. So you're going to have 5x, that when you square it, you get 25x squared. Here you get 6 squared, because when you square 6, you get 36. So my a is 5x, my b is 6. So 2ab. Let's find 2ab. So it's going to be 2 times a by x, b, 6. So what is this? 2 times 5 is 10, times 6 is 60.
Can you
Then,
move the paper up, please?
sorry, x. Okay, so you have the middle term. You have this value matching here. So, and the sign, you don't care about the sign at this moment. You're going to take care of the sign at the last step when you write a, in this case, minus b squared. So again, these two quantities match. So then the trinomial is a perfect square. Okay, so a minus b is just a is 5x minus b, which is 6 squared. So that's the answer for part C of this problem. So now let's work another example. So we have example 6 on page 450, and we're gonna factor 16x squared plus 40xy plus 25y squared. So is this a perfect square trinomial? We don't know. Let's find out. So we're gonna have to rewrite the first term as a perfect square. So it's gonna be 4x, because when you square 4x, you get 16x squared. Here, you're gonna write 5y, because when you square 5y, you're gonna get 25y squared. So now, 2ab. So that's the crucial part to find whether this is a perfect square trinomial. So 2ab is 2 times a, which is 4x, times b, which is 5y. So this is 2 times 4 is 8 times 5 is 40, and x times y is just xy. So you see that they are matching. So this is another perfect square trinomial. So now we're going to write a plus, because the middle term is positive, so plus b square. So this is a for x plus b 5y square. So that's example 6. So now you're gonna solve a couple of problems from the exercise set. This is like 6.4 exercise set on page 454. So now you're gonna solve 48 and 52 only. 48 is x squared minus 10x plus 25, and 52 is x squared plus 24x plus 144. Okay, solve those two problems, and then we're going to finish our lecture with another special form. So when you have the sum of the difference of two cubes, a cube plus b cube, or a cube minus b cube, the way to solve this problem is that you have to rewrite the first and last terms as perfect cubes this time, not perfect squares, perfect cubes, and then you use the formula. So we have formulas for a cube plus b cube is just a plus b that multiplies a squared minus ab plus b squared. Or when you have the difference, a cube minus b cube, you just write the difference of the cube roots, a minus b, and you multiply that by a squared plus ab plus b squared. So be careful about these signs. You're going to have the opportunity to have this in your formula sheet. So let's work a couple of examples. So I have example 7 on page 451. So we're going to factor x cubed plus 8. Okay, so now we're going to rewrite this as perfect cubes. So x cubed is just x cubed, and 8 is just 2 to the cube, because if you multiply 2 times 2 times 2, you're going to get 8. So now you know a and you know b. So a is x and b is 2. So you're going to write a plus b a squared minus ab. So you copy this from your formula sheet, and then just replace every term here. So you have a is x plus b, which is 2. Then we have a squared is going to be x squared minus ab, a times b, so 2 times x. Then finally plus b squared, which is 2 squared is going to be 4. So that's example 7. Then we have example 8. Example 8 on page 452. So here you're gonna factor 27 minus y cubed. So again, first you're gonna rewrite this as perfect cubes. So 27 is just 3 to the third power minus y to the third power. So now you know a and you know b. So now you have a negative sign here. So you're going to have a minus b that multiplies a squared plus ab plus b squared. So a, what is a? Is 3 minus b, which is y. Then you're going to square a, is going to be 9. Then you're going to add a times b. So this is plus 3 times y plus the square of the second one is y squared. So that is going to be the answer for that problem. Uh, Finally, we have example 9. Example 9 on page 452. So example 9 is 64. We're going to factor 64 x cubed plus 125. So that's problem example 9. So we need to rewrite this as a perfect cube. So 64 is going to be 4 to the cube, because 4 times 4 times 4 is going to give you 64, and x times x times x is going to give you x cubed. So that's the way that you rewrite this as a perfect cube. And 125 is just going to be just 5 to the cube. So we're going to need to write a plus b that multiplies a squared minus ab plus b squared. So a is 4x, b is 5. Then we're going to square a, so it's going to be 16x squared, because 4 times 4 is 16, x times x is x squared. Then we have negative a times b, so 5 times 4 is going to be 20, and then we have x here. And finally, we're going to square the second term here, so 5 times 5 is going to be 25. So, and that's the final answer for this problem. So you're going to solve just a couple of exercises. You are not going to have the sum of the difference of cubes in the exam, but you might have the sum of the difference of cubes in the quiz. So and you can practice this. It's just be able to use formulas, because that's the skill that you are learning here, how to use formulas, because the formulas are giving you a shortcut to do factoring. So this is 6.4 exercise set, and now you're gonna go to page 454, and you're gonna solve 2 more problems to complete our classwork for today. So 88 and 94. 88 is x cubed y cubed minus 27, and 94 is ax cubed plus 27y cubed. So with this, we're going to complete this section. I'm just going to project you the web page where you're going to need to find the information that you need for you to be able to take the exam the next week. So you're going to need to practice how to get the information. So you're going to go to proctorio.com. So you're going to go to proctorio.com /support, and then you're going to find the information that you need to take the exam. So this is the web page, and you just scroll down, and you're gonna see everything that you need to know about taking the exam online. So you have here setting up Proctorio. So you need to install Google Chrome in your computer, and then you're going to install the Proctorio extension. And once you have that, you're going to take your exam. So it's not going to be very easy. You're going to do it at home, comfortable. And this is going to be like another quiz that we have had online in the past. So I'm going to stop the recording for you to continue working.